Okay, we are very glad to have Professor Moshood with us today, who will be presenting on his portion about computational BIM for digital assets delivery and FM. So for my part, right, it's just going to be very quick, so I'm not going to eat into his time. Essentially, what I'm just going to share with you is what my firm is developing as our own kind of a workflow. And eventually, we want to also set up a platform for facilities manager or anyone, it could be homeowners and designers, to be able to understand the existing indoor environmental conditions for their individual houses or commercial properties and so on and so forth. Okay, so if you have joined the series earlier, like what Wen was sharing with us, you would have seen this slide that I've shared with you. This is my current workflow in my practice. So when we start on any project, be it A&A or for a new build, what we will try to do is we will get site-specific environmental data. You see from the left-hand side are pictures of indoor environments. On the right-hand side are external environments, because it's very important to be able to find the exact conditions for each site. Because what we have now is generic information that are generally from the airports in each of the simulation softwares. So it's good to get the exact information so that you know what is the situation and how you can address it through passive or active design strategies. These are the kind of information that you can log on for. Okay, so you could log humidity information, temperature information, and the lighting levels. So this is what I'm currently researching on. I want to be able to set up this platform called EnviroWell, in which we will be able to tap onto information. So it doesn't mean that when the client want to do the design, then the designer comes in to do whatever that I just described, which is all the logging, because this is a limited timeline in which you can log. Because once the client engages you, maybe you have around 1 to 2 months to design for like a render house design project. So this amount of time that you log is not the actual accurate information. So again, we have to do some extrapolation from there. But say, for example, if we have this platform and we are able to monitor your indoor environment already, so what happens is that you will be able to the client will just be able to pass their information to the designer. The designer can see, oh, okay, actually now your existing space is very lacking in natural daylighting, and there's also a lot of heat gain due to the western sun, and so on and so forth. And this premise of this is that we want to be able to get all of this data. A lot of us is really very used to having wearables, for example, your smartwatches or even those Fitbit wristbands, right? All of this already are monitoring our own physical health. And you can even measure your oxygen levels ever since the COVID came up, your sleep schedules, and the number of steps that you have. Then why do we not apply this to our environment, whereby we can already tap onto existing technologies to log all of this information? So what we want to do is, this is the timeline that I'm doing my research now. And in general, what we want to be able to log is the temperature, humidity, wind circulation, air quality, and light levels. So all of this will come up to a web platform, and this information will then be easily monitored by the person who occupies the space. It could be like a condo owner, or even HDB owner, landed house owner, or even commercial properties and industrial properties. And then once he wants to release this information to the designer, then the designer can access from there. And eventually, we will also, I'm also trying to do like a kind of a smart machine learning thing, so that we can even be able to extrapolate information and then make recommendations based off on their lifestyles. And yes, so this is just nice. for us. 12:15, I will hand over to Professor Moshood. Has done a lot of research on indoor air quality as well, right? I've been reading up on your LinkedIn profiles, as well as the very interesting indoor air cartoon, which is very palatable to a lot of end users. Okay, so over to you, Professor Moshood. Okay, and then after that, we'll have our Q&A.
Okay, will I be able to share my slide now?
Yes. Let me try. Let me allow you. Let me stop sharing. Okay.
Okay, let me try to share. Okay, can you see my screen now? Okay.
Yes, we can. Thank you very much.
Okay, let me put my slide. Thank you very much. I hope you can hear me very well. And
yes, very clearly.
I thank everybody for coming to listen to my presentation. So I have 15 minutes, so I will try to do justice to the time because I know you guys are very busy. So the topic is computational BIM for digital asset delivery and facility management. How to make it effective. So this is the key point today. How to make it effective. So throughout my presentation, I'll be presenting based on this fundamental question: how to make it effective. During the discussion, I hope we can also talk about this, and most importantly, when you leave presentation today, I want you to take this question away with you today and keep asking this question when you are practicing. I know all of you are experts, so you know what you are doing. I just want you to be conscious by asking this question. Now, going to the key terms in the question, in the topic itself, facility management. I want you to look at what is facility, first of all. I want you to look at facility in the context of human being. So human being is a whole body. So a whole body could be like a building, which we call facility in this context. And in human body, we have different organs and different parts. So these are assets because they provide useful outcome to us. They provide value to us. So we call them assets. So similar to building, we have different kind of systems like HVAC system, plumbing system, electrical system that gives usefulness to each one of them gives usefulness to the end user, the customer of the building. So how to make them useful? How to improve their performance? Normally, human beings, we can do it manually, but that would take a lot of time. By saying it take a lot of time means it will consume a lot of resources from human beings. To reduce that, that is why we want to dive into the use of digital solution. And by talking about computation, like Wumpi has already defined it, I won't go into it, but the whole idea is to look for possible way of generating these assets so that they can provide usefulness. And when you put all this usefulness together, it can make your building like your whole body, human being body, to perform very well. So that takes me to this question, to this point. It will be impossible for facility managers to actually manage what they cannot see. To doctors, a doctor cannot operate you very well, or they cannot maintain your body to perform very well if they do not understand the components of the body. So as facility managers or people in charge of ensuring the performance of our building, it is very important for us to have good information about our assets. So, but for this to happen, it has to start from the beginning, from design stage, construction stage. Now, let me focus on the construction stage, for example. If from the construction stage, the documentation of all the assets, the generation of information about these assets are not properly documented and delivered to the facility manager, problem will start. So that is why it is very important to use computational solutions to actually verify the quality of information submitted by the contractor, the accuracy and the completeness of all these things. Because if we don't take care of this issue, then there's going to be a problem. So this is one of the research that we did at SIT to see how can we develop a solution to ensure that we help facility managers to accurately confirm that the information submitted by the contractors are actually accurate and also complete and relevant to the context of the building. The larger your building is, the more important that you need to be able to have this kind of solution that we develop to verify the accuracy of the assets submitted. So at your place of work, ask yourself this question. Whenever you are giving information by the contractors, to what extent are you sure that this information is accurate? Because if you are not able to answer this question, then we see a situation in which people don't actually use the information. We don't want that. So how to make this effective? First question we need to ask ourselves is, for us to manage our building, how long is it going to take us to consume our resources like time, energy, manpower, and so on and so forth? And to be able to make sure the building components can actually give the performance required. Because if this doesn't happen, then the value delivered is going to be compromised. But in the community of computational BIM, we have a lot of professionals. I've noticed something, that we have several professionals, but most of the time, some professionals, even some students that are being trained to go into the industry, they focus a lot on the use of this computational tool, but they forget about the purpose of it. So the purpose of it is to actually solve problems. To solve problems in a value-oriented manner, to ensure that the facility managers, if they want to manage their assets, to ensure that their facility is well operated and well managed to give the required performance, they don't waste a lot of resources. But most of the time, this aspect is usually compromised. So one of the things I do in my duty is basically to train students and also to engage industry professionals to ensure that they think critically and apply the skill they have, the technical know-how they have in defining the problem accurately. Because building will always have problems. The components of building, which are the assets that are supposed to give you value, they will always have problems, just like human beings, just like human body. But the ability to know where the problem is, the ability to know the extent of this problem is vital. But if you don't have accurate information about the asset that you have, you won't be able to define this problem. And that is where the problem actually starts. The problem of not being able to know or to define the problem is actually another source of problem. So, like I've said earlier on, we did research to ensure that, okay, you have complete assets required and these assets are accurate. Why is it important to focus on problem solving? Because nowadays, a lot of people are talking about digital transformation, which is very important and right on time, which is very good. People are talking about it. But we also have to be cautious in the extent that while we are talking about this digital solution, we need to be asking ourselves, are we really achieving the purpose of it? So I came out with this statement. Whenever we are creating a solution, we have to pay attention, give attention to the end users. Your solution can be good. You can come out with a computational tool or a computational solution that can actually be very, very good on paper, so to say, on paper. But when you actually apply it in the context of the real life situation, you realize that this solution that you've created might actually cause more problem for the end user. When I say cause more problem for them, I mean it might actually cause them to actually spend more time, need to go for more knowledge, and at the end of the day, unable to provide the required level of usefulness to the end user. So these are some of the things that we need to consider when we are developing our computational tool. So remember my question at the beginning of the presentation, how to make it effective. So what we are looking at from this question is how to make it user-friendly, how to make it not to be another source of problem that will consume a lot of resources with little usefulness being delivered from the solution provided. So if you want to understand more about this concept, about what are the things that we need to look out for when we are talking about usefulness, what are the determinants of the sources of the usefulness, and what are the determinants of the or things to look out for when we are talking about investor resources. You can look at these articles I put on this, I reference on this slide. Later on, you can find it on Indo Cartoon Journal. So I dive in details about this concept. Because if we don't understand this concept, I'm afraid that we come into a situation in which we have a lot of experts that knows a lot about computational BIM. They know how to use Python, they know how to use Dynamo, they know how to use different kind of digital solution that can aid generation of building information. But at the end of the day, the end user of the usefulness are not getting the usefulness they require from the solution that you actually delivered. So computational BIM itself is trying to help you generate a solution. But how will this solution solve our problem should be at the back of our mind. These are examples of some of the research that we've done. The first one here, identification of errors in BIM models. This is a real life situation. So this was actually led by one of my students. When she did 12 months, we call it integrated work study program, we can call it internship, in a company in Singapore. And he worked in the FM department, and in this company, they are actually helping industry to actually solve their problem in terms of FM. But she, based on her experience, she realized that many times building owners do not have accurate asset information. So and if they don't have it is going to be very impossible to effectively deliver value to the building owner, even to the facility manager that will be operating the building and managing the building, and most importantly, the end user, the building occupant. So she came out with an idea of how to develop this solution under my supervision, and we were able to develop a solution at least at preliminary level on possible ways to actually identify these errors. Another research actually continued from that, now using Python to address the situation. Another important thing about facility management is ensuring you are able to transfer your asset information, which goes to the third point here, an automated solution for importing critical asset information into BIM model. So how to do this? Because if you don't know how to transfer your information, you might not be able to create a solution that will give value to you. I know you might not be able to create a solution that will maximize your usefulness from your invested resources. I would love to dive into the details of this concept of value is equal to usefulness of our invested resources, but because of time, I won't be able to do so. But I've given you a reference to an article that you can read for you to better appreciate that. But I wrote the article in form of a story so that anybody, irrespective of their expertise or area of discipline, they will be able to understand the concept very well. So another one is the automated retrieval of photo data, because many times in facility management practices, we have to take a lot of photos, you have to document them, and if you are not able to streamline the process, use lean thinking, look for ways to ensure that you actually reduce the manpower required, the time required, that might cause a lot of problem for the building owner, basically compromise the value delivered to them. So when I say reduce manpower, I'm not actually saying that we let people lose their job. People are afraid of digital solution nowadays because they don't really understand the main purpose of a digital solution. The purpose is to make you to speed up the process of solving your. This thing is not true. There was supposed to be a photo here, but never mind. But you can look at the concept here. This one shows that digital solutions are only meant to improve the process of solving a problem. However, human beings still need to figure out how to solve the problem themselves. Okay, so in this place, I put a lot of concepts about the lean thinking process because I dive into a lot of lean thinking also. Then here I show that digital solution is just a component of it, which is very, very important. Don't get me wrong. But if you don't, my point is, if you don't know how to solve problems, if you don't know how to solve problems, your digital solution will not be useful to you. Because by knowing how to solve problems, it will help you to come out with a better, relevant, useful solution that can enhance the value delivered to all the stakeholders involved. So that goes to the next point. Then how to solve problems. Because if you don't understand this, you're going to have a lot of problems. And I'm talking from experience, dealing with industry professionals and also dealing with my students. Many students, they have fantastic ideas of how to come out with a solution using computational BIM, because at SIT, we do teach students all these things. But you realize that when you ask them to come out with a problem statement, they will actually be giving you solution statement of what they want to do. And don't think these are because they are students. Just I want you from now on pay attention when people are doing presentation in the industry. There are so many people in the industry that can, that actually knows how to solve problems. Don't get me wrong, but I'm just saying that pay attention. Realize that when people what people refer to as problem statement, most of the time are actually solution statement. The solution, that is what they want to deliver, not the gap in performance. So the first question to ask is this: what problem do you intend to solve? So then we need to go back. What is the meaning of a problem? The problem is the gap in performance. Gap in performance from your current practice and your future expected practice. So the gap in performance in the two stages will be your problem. So that is, you want to reduce that gap. You want to reduce the problem. And this might need you to do a lot of research to understand what is the current practice, what are the performance out of this practice, what are the key determinants that you're looking out for. Then the future state that you expect to go to. What level of performance do you require? Then from there you can define the problem. If you don't do this, your digital solution or your computational BIM solution might actually be solving a problem that does not exist. So then you need to understand why is it so important, because at the end of the day, you need to convince the stakeholders to invest money into your digital solution. They need to appreciate why this thing is very important to be done. But if you're not very clear about that, it's going to be very difficult to actually justify the purpose and the problem this solution you are trying to develop is going to deliver. The value is going to deliver. It's going to the purpose also. Then one thing is to have a problem. Another thing is to understand the cause of a problem. Let's pause a little bit. Ask ourselves, whenever we are coming out with our digital solution or using Dynamo or Python or different kind of software to actually come out with a solution that can improve performance in the building delivery process, how many times do we take time to actually understand the contributing factors or the causes of problems that we are trying to solve? Because your computational BIM supposed to address these causes. Because when you are putting your parameters, moving your building information, how to do it in a creative manner will be a function of your knowledge of the contributing factors to the problem they're trying to solve. But how many times do we pay attention to this? And this sometimes is not our fault because of the time, people are rushing and everything like that. But at the end of the day, it's still very important for us to pay attention to this, because if you don't pay attention, then the whole idea of developing our solution will not be useful in the first place. Then from there, we proceed to the solution, and we also need to test it. So these are the things that we know. So the point I'm trying to make here is this. Although computational BIM is very popular in the industry now, a lot of people now can easily find information materials on how to solve this, or how to have these skills and knowledge about it. If you go to YouTube, you can get a lot of videos about it nowadays. And if you go to universities, a lot of universities are teaching it now. At SIT, we teach students. First of all, we start with teaching them BIM, Revit. Then from there, we proceed to computational BIM. Then we move to Navisworks construction, and so on and so forth, also for facility management. But I want to advise, and I want to believe that you would agree with me, because you are experts in the industry. When we are talking to our staff, or when we are in a meeting, let us be conscious about the problem our computational BIM solution is trying to solve. Because the computational BIM itself is not the final solution that we want to solve. It's a solution in terms of possibilities. But to solve the problem the end user are facing in terms of building performance, then we need to ask questions about what is the problem with regards to the building performance. What are the contributing factors to the problem being experienced in this facility, the building? And from there, we go into what are the possible contributing factors. Okay, maybe it's this asset, maybe it's the HVAC. Then from the HVAC, why is the HVAC having problem? This knowledge will move, you need to take this knowledge and apply this knowledge when you are developing your computational BIM solution, so that you can come out with an effective solution that can be applied in the right context. This philosophy, this idea, I've written a lot about it, and I try to share with the industry from the indoor air quality context, because I'm an expert in the indoor air quality side. But air quality is just one aspect of the building. We have other parameters of indoor environmental qualities, and it can be applied to any field. It can be applied to the design stage also, the construction stage also. So let's go back to my first question: how to make our computational BIM solution effective? Effective means here how to enhance the value delivery. Value delivery means maximizing the usefulness delivered or gained from invested resources for stakeholders, the building owner, facility managers, contractors, the building occupants. And many times there will be conflict between the stakeholders. But at FM stage, then you need to focus on how to manage the conflict between the building owner, facility managers, and some of the contractors also that will be doing renovation and so on and so forth, and most importantly, the building user. How many times do we ask ourselves this question when we are developing our computational solution? That is my purpose here today. That is my purpose of my presentation. Is to enhance the critical thinking about increasing value of our computational BIM solution. Okay, so purpose today is not to teach you how to develop computational BIM solution, but how to apply it, enhance value. And when you enhance value, it has to be the economy of the country in the long run. So I will stop here for now because of time. So thank you very much. Can you hear me?
Thank you very much, Professor. Okay, so we are open up for Q&A now. for the next 5 to 10 minutes. Because usually we wrap up at around 12:45, but maybe we just have it until 12:50. So it's open to the floor. Anyone with questions, feel free to voice out, unmute yourselves. If you're shy, you can also type in a message and then we will be accordingly.
So, I mean, while we are waiting for questions to come in, just remember this: you cannot manage what you cannot see. I think there's a question here. Can the slide be mailed to us? Sure. I will share the slide with one way and take it from there. Is it okay like that?
Sure.
Yes.
I have one. Actually, it's a problem statement. So to share. So what I understand now when we are talking about assets delivery, right? So it's about trackings, parameters. But the thing is, the parameters, right, comes from different disciplines, different parties. Clients will have their own agenda. Consultants will have their own agenda. Then manufacturers have their own sets. So the key thing is how much information is enough. So for instance, when we're going for design, so we'll go for compliant needs, right? Then we go for construction, then it's go for costing, quantity take off, so and delivery timing. When we go for this FM is actually on the assets performance, right? Even now there's actually a carbon accounting, embodied carbon accounting. So and all different disciplines, different background people have their own agenda. They will just do just enough. Contractually, I'm bound to this. Why do I need to do more? So the issue is with this contractual issue is good. So I just deliver what I have. But the thing is, the just enough is actually not enough when we are looking at the entire life cycle. So therefore, how do we actually engage this computational approach to enhance the entire or compact the entire processes? Maybe this is just a question to throw out. Yeah.
Okay, let me try to answer that first. You asked a fundamental question: what information is enough, right? So that's my point. For you to understand when information is enough or not enough, what is the criteria you are using to judge that? And this criteria will be a function of the knowledge of information you are trying to solve. Now, when I say solving a problem, whose problem are you trying to solve? The problem of the building owner, the problem of the end user, the problem of the contractor. So that is why you also need to understand what is the meaning of value to the contractor, what is the meaning of value to building owner, what is the meaning of value to the end user, for example, building occupant. Then from there, this understanding, first of all, we know the problem everybody is trying to solve, because in reality, everybody is trying to solve this different kind of problem. So this definition of problem will at least reduce the risk of not just generating information without gaining anything out of it. But in a practice in which we just focus on generating information, generating solution, without understanding or with little understanding of the value everybody is trying to gain, and most importantly, the end user, the building occupant, we run the risk of actually generating information that are not actually useful, not supporting anybody. And to generate information costs a lot of resources also. And when you are generating information, it's not giving you the value that you want. After some time, people will be reducing the effort required to generate information. By reducing this effort also, that leads to another set of problems, because you won't have enough information to be used. And that is the problem we are facing now. We have a lot of experts. But how can we use our expertise to solve problems? It's a different question entirely. So that means you also need to understand the determinants of value to different stakeholders. And the reference I mentioned in my presentation try to talk about that on the definition of terms for each of these stakeholders. So for you to know when information is enough, you need to know the problem you're trying to solve. That's perfect for now.
Yes, exactly. It's actually the value-driven information needs, right? But the thing is, different stages they will have different needs. So the value is different. So what we were thinking is earlier on is to establish maybe a system. So where a system that has a compilation of everything. So when everything is there, so it is actually a building information modeling, for instance. So it's a data-rich component. So anyone can incorporate whatever information needed. So, but the thing is, different companies will have different standards, naming conventions, details. So therefore, it's very difficult to standardize. I mean, from agency's point of view, it's always on standardizations. So therefore, this is actually an issue. Yeah, one of the issue I see.
One of the issues. So that aspect needs to be addressed on how to put everybody on the same frequency. Yeah. But at the end of the day, even when you are doing the standardization, you also need to pay attention to the concerns of every stakeholder. So I will share the link to the articles I'm talking about so that in case people want to read, you can read.
Okay. That's good.
The link
Very
is there.
nice of you to share.
It's in form of a story. In form of a story, you can read it. Yeah.
There's another question. We'll also wish to ask whether can computation BIM skill sets be also shared and teach in part to IT professional, since there is huge portion on Python programming for computation BIM.
Okay, let me try to answer that one. In one of the articles, the list of articles from my students' work, actually I did one with a student from computer science. So that is where we need people with expertise from built environment and people with IT experience to work together, and we can benefit from each other. So for that particular research, I put my students with knowledge about built environment with students from computer science together, and they taught each other different things. Feel me, right? So definitely we need people with computer science. We really need now to come into this field. But these people also need to understand some basic concept about the built environment, and most importantly, they have to work with experts in the built environment for it to work together. I mean, we can't work separately. We have to work together because there are too many things we know about IT that we do not know. There are so many things we know about built environment that if they start learning now, it will take forever for them to learn. So we need to work together. So while we are waiting for another question, I hope that when you read these articles and the link to the indoor cartoon article I've just shared now, you'll be able to appreciate my own definition of usefulness, my own definition of invested resources. And I know that we don't have the solution nowadays to, I mean, at this present moment, to actually define most of the parameters I put in the equation. So that will be another source of research that from me and my team are trying to explore how to come up with a solution that can accurately in real time help us quantify this information. And if you go to the construction industry now, a lot of people are using AI to monitor people's movement, to monitor risk value on construction site. I mean, these are examples of how we come up with solutions to help us determine possible root cause of a problem. Okay? The effort to develop solution will keep continuing, but we should not forget one thing. Solution is different from problem solving. Solution is just a process in an effort to solve. Digital solution is a step in solving a problem. The purpose of digital solution is to enhance the process of solving a problem. We human beings still need to know what we put into the digital solution, how we develop the digital solution, how we manipulate the digital solution to what? To solve our problem. You can understand my point here. How So we know how to define the problem first of all. Somebody responding to the previous question. Okay, especially diploma in technology.
Yeah, that's true, because you already have a basic information regarding architectural technology, and then you are also having experience as an IT professional.
Yeah, I mean, that's a good point. That's a good point. It's a bridge, like the person mentioned, is a bridge. So that means in the university or any IHLs, we need to teach students a lot about IT now, but in the context of built environment. But that doesn't mean they do not need to work with computer scientists. They still have to, but at least it will push them to a level in which they can easily communicate and communicate effectively. So I'm glad that at BC Academy you have this kind of program. Yeah, it's a good program. So that is something that should be continued, and because it will help a lot in bridging the gap. Yeah. The last thing you want is for you to have knowledge about built environment and you know nothing about IT side. That's going to be very bad.
Yeah, there's another question now. Will SIT open part-time bachelor degree? No, Professor Moshood. Do you know?
For now, we don't. For now, we don't have part-time bachelor degree, but you never know in the future. But that will be a decision made by my superiors. Yeah. But in my program, we do have something we call work study post diploma. It used to be called ELP, N and Learn last time. So we hope that students can come and take some modules at SIT. When they taste it, they like it, and hopefully they can apply to work at SIT full time. But we do have part-time for people that move to the master level. We have part-time for that, but for now, we don't have part-time for bachelor degree. And I know it's a challenge because people want to work, get money, and at the same time study, right? Hopefully, we can have something like that. Yeah. But it's a very valid question.
Yeah. Maybe we can ask BCA to sort of incorporate together like a work study program. Right, Wu-Wei.
So while we are waiting for questions, please do not forget my key message today. My key message is how to make our computational BIM effective. How to make it effective.
Yes.
You will not be surprised don't be surprised that you see students from polytechnics, students from universities, and BCA being part of the BCA Academy being part of the polytechnic. Don't be surprised that you have a lot of people with very good knowledge about all these things nowadays. A lot of my students actually know a lot about these things, and a lot of our graduates. In fact, we do have graduates that are now working as a computationalist. That's what they do. That's what they do now. So, but what we are doing at SIT is that while we provide you basic knowledge about built environment, about digital solution, we focus more on what is more important than that also, and that is how to solve problems.
How to frame problem also, frame the question.
Very good. And that is the starting point of how to solve problems. You must be able to define problem. And we also need to understand what is the meaning of problem. I want to give everybody an assignment. I mean, I like to use that because as a professor, you always give students an assignment. Saying that. Pay attention, observe when people write, when the people are presenting and they say, okay, problem statement, just pay attention to their problem statement. You realize that the problem statement they are giving is about the solution they want to give. It's not about the gap in performance because current practice is supposed to be giving certain performance. Future practice that you expect to be at supposed to give an emphasic performance. So what is the difference between these two states? That is your problem. For people, instead of that, people will say, okay, I'm going to create this solution. That is a solution statement. It's not a problem statement. When you start like that, you've already confined yourself in a box. It's going to be very difficult for you to know which information to get, and not just get information, but in what context. What is the human component of it? What is the machine component of it? What is the material component of it? What is the process component of it? Because all these things can introduce confounders, can introduce problems. Because root cause also is a form of a problem on its own. So just to put another analogy here, if your room is wet, or let's just say your office is wet, normally we think of finding a towel, wipe the floor. Towel is a solution. Wet floor is a problem because it's supposed to be dry, right? Dryness level is very, very high. I mean, wetness level is very high. We want it to be lower, so there's a problem there. So people use solution, which is the towel to wipe. But if we don't go down to the cause of the problem, why is this floor wet in the first place? By doing your investigation, you might realize that there's a leaking tap somewhere. If you figure that one out, you fix the source of the leakages, then you've given a reliable solution. Towel in this context is not a reliable solution because every time there's a wet floor, you need to buy more towel, use more towel, a lot of time, energy to do so. So my point is, please, while we are developing our skills, our knowledge in computational BIM, let us also pay attention on how we can get the best out of these skills, out of this computational BIM. Because at the end of the day, what people want from you is to solve problems. It's not really the digital solution. If you think about it, it's for you to solve problems in a reliable way that will not cost them more resources in the long run. So we need to learn that it's a continuous improvement effort. Real life context is very dynamic, very complex. Like when we rightly mentioned just now, it's very complex. But if we have this mindset of solving problem, and also that solution is different from solving problem, I think we'll be on the right track.
Okay. So any more last questions before we wrap it up? I think, yes, what Professor Moshood has reiterated is very correct. We need to be able to define the question properly and then work together among all stakeholders with the skill sets that we have. And especially if there are hybrid people like Royston, who have pointed out that he has a background in building, architectural technology, and now still working at IT, then we can really bridge this gap so that there's feedback from both sides of the expertise. Then we can better frame the question and tackle the question together.
And most importantly, develop your digital solution appropriately.
Yeah.
It also gives you direction to go to in developing it. We need the context of developing our solution appropriately. And that is where problem definition comes in. It helps you to define the context appropriately.
Okay. So with no other questions now, we will wrap it up. We will share all the slides as together with the YouTube video. So what Wenwei had done very kindly in the beginning is to post the YouTube channel. So all of you who are interested, you can subscribe to this channel. And then with this upload, there will be a link below where we will share the slides that have been presented earlier today.
Yeah, and in my presentation, a particular slide or a particular figure didn't show, right? So when I send my slide, you will see the figure that I wanted to show. Yeah.
Great, wonderful. Okay, so thank you everybody. We will see you again next month, and thank you once again to Professor Moshood for sharing with us.
My pleasure.
Hope to see you around.
My pleasure. Thank you very much for inviting me.
Okay.
And don't forget on problem solving. That is my mission. My mission to the industry.
Yes.
Focus on solving problems.
Okay. Thank you.
Thank you very much.
Yes. Thank you. Thank you, Prof.
Thank you.
Thank you, Lashes. Thank you.
Thank you. Thank you, Wei.